Hi, welcome to today's lesson. Today's lesson is on a topic called density. And again, what you should have already, you should already have your notes copied in your notebook. So that what you're doing is following along in your notes while we talk about it, and then adding stuff to it that I write on the board and explaining it. So, what is density? Well, density is a measurement of the mass of a substance per its unit volume. So that means what we need to know is we need to know the mass of the object. We also need to know the volume of the object. What is volume? Volume is the amount of space that an object takes up. Okay? Well, how much space it takes up. So there is an equation in your notes, and it's density equals mass divided by volume, m divided by v. Right? So now the one thing I always love to explain in regards to density is that letter C, the density of a substance does not change whether you have a truckload. If I had a truckload of gold, or if I had a single little chain that you'd have around your neck, if all I had was just one of the little pieces from that necklace, the density, and that was gold, that density for that chain link would be the same as the truckload of gold. And now you're going, wait. There's no way that a truckload of gold's mass is the same as the mass of one little piece of a necklace chain. But you got to remember, it's mass divided by volume. So what we're really doing every single time is we are always comparing it with the idea of what's the mass per volume, and that volume is really 1 milliliter. So we're really always comparing it to the idea of 1 milliliter of the substance. I'll make that look like milliliters. There we go, that looks like milliliters. So we're really always comparing it to, well, if I had 1 milliliter of this substance. So even though I have a truckload of the gold, I'm really looking at what's the mass of 1 milliliter of it. Even though I have a little bitty chain link of this necklace, I'm still looking at what if I had 1 milliliter of those necklace pieces. Then that mass, because it's a pure substance, then that mass would be exactly the same. And in the case of gold, it's 19.3. So gold's density is 19.3. Always, as long as it's pure gold, right? So that was really what letter D talks about, is that the reason for this is that density is always measuring the mass of 1 milliliter of the substance. Now we can also determine if a substance is actually gold, right? Or if it's silver, or if it's titanium, or if it's any specific substance. And what we can do is we can figure out its density, because the densities of all of the pure substances are known numbers. Now, where would you get that known number? Well, you have to look it up on a chart, right? And you could Google it. You could Google the density of the substance. You can go to books that have those densities in them. They're listed. Scientists have already determined what the densities are. So you're walking through the parking lot of the school and you find a piece of a rock, and it's all shiny and it's gold, and you're like, I wonder, is that a real piece of gold? I might be rich. So what do you got to do? Well, what you have to do is you have to find out the mass of it. You got to find out the volume of it. So way back when my wife and I got married, I bought a wedding band, right? And it was gold. I don't wear that one anymore. Now I have a new one. The only reason I have a new one is my original gold one got small and I couldn't get it off, and I finally had to take a bolt cutter and cut it off, and then I got a new one. But if I had that ring and I wanted to find out if it was really gold, what I would have to do is, one of the first things I'd have to do is I'd have to use this, and I would have to measure its mass. So I would place the ring on here, and then I slide these things across and find out what the mass is. Now, something I want to show you in regards to using these things is that if I put this thing on there, I would find that the little slider, get rid of this, the little slider in the bottom going across, there would be the spot that would be 3. There would be this. Those would be the little markings that are on there. And the little pointer would point, oops, actually, I'm going to go a little bit farther. And so on, all right? So, and the pointer would actually point like this. right there. Now, what we have to do is we have to figure out, well, what is that mass, right? Now, every device that's out there scientifically, you can always estimate one more decimal than what the device is designed for. So we have to figure out is what are these little lines in the middle? What do those mean? Well, those are tenths. Because this is 3, this would be 3.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 4. Okay? And then this line would be 4.1, 0.2, 0.3, 0.4, 4.5. So is it pointing at 4.1? Well, if you look close enough, no, it's not. It's actually just a little bit below the 4.1. So it's a little bit below the 4.1, then that means this mass would actually be like 4 point, and we know it's not 1, so therefore this spot would be 0. Is it halfway between the 4 and the 4.1? No, I don't think so. I think it's a little bit higher than that. Okay, it's not halfway in between, so that would be, if it was halfway, it would be 4.05. If it's a little bit more than that, I would say it's probably about 4.8. I'm sorry, 4.08. So, because it's not quite all the way to the point of being 4.1, it's not at the halfway, which would be 4.05, so it's halfway in between. You could also say maybe it's 4.07. I would agree with that too. Okay. I don't necessarily agree that it would be 4.09. And I definitely don't agree with 4.05. All right, and again, it's an estimate. You estimate one more decimal than what the device is designed for. Now, you can't go any further than that. I can't make it, well, I think it's 4.08217543.8. I can't estimate all of those. Right? The only thing that I can estimate is one more than what the device is designed for. I can look at this and decide that, yep, it's not right on the line. It's a little bit less, or it's a little bit more than the line. Okay? So what we're going to do is we're going to take this and go, well, okay, well, that's my mass. So I have density of my ring equals the mass is 4.1 grams. Okay? We're going to try and find out, is my ring that I bought way back when I married my wife, was it actually gold? So that gave me the density. Now the next piece I have to do is now I'd have to find out the volume of my ring. Well, my ring, just like this one, it was round. Well, trying to like mathematically figure that out, good luck, that's going to be hard. So what you do is you use this. You use a graduated cylinder. And what you do is you pour a little bit of water at the bottom, and then look at where the water goes. And then after that, then you take the ring and drop the ring in, and the water is going to go up. And when it goes up, then you figure out what that line is, and then you subtract those two. Okay? And once you subtract them, then what that difference is, that's the volume of the ring. Okay? So if we were to do this on the board again, then the first time that I put this thing in, here's the graduated cylinder. Right? Here's the markings. This would be 10, 20. The first thing we got to figure out is what is each one of these markings. On the last one, when we were looking at the balance, each marking was 0.1. What do these represent? Well, these represent 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Each one of these represent 1, right? So this means on this one, we can't go to the hundredths place. This time we're only going to estimate to the tenths. We're going to go one more than what the device is designed for. So the first time when I dropped my ring in here, let's say it was right there. Right? Is that on the 15? Nope. Is it on the 16? Nope. It's kind of in between it. So currently right now we can say it's at 15. And then I would say if you looked at it really closely, it's about 15.6 milliliters. It's a little bit more than halfway, right? But it's definitely not on the line of either one, right? Now I take my ring, drop my ring down in there. And after I drop my ring in, then it goes up to here. And once I do that, this time now notice it went right across that line. So I would call that, because it's right on the line, that's actually 16 point, and if it's right on the line, we got to say, well, it's 0. That tells anybody in regards to significant figures that it was right on the line, right? So now when we look at, well, what's the volume of a ring? I got to take both of these and subtract them. Well, that's 0.4. So we're going to put that up in our equation. We're going to go, my ring had a volume of 0.4 milliliters. Once I've done that, now all I have to do is Now I just got to like divide these out. And I will tell you that your computer actually has a calculator. Okay? You just click on the little 4 squares in the bottom corner left and go up and there's a calculator. Right? And you have multiple different calculators. Ultimately, what you're going to want to do is you're going to use the scientific one. So if you click on it, you can pull down and get a scientific, and that's how you got the exponents that we used earlier. So, all right. So if I divide this thing out, if you divide this out, what you'd end up with is you would end up with an answer of the density of the ring equals 10.2, and it's grams over milliliters, because neither unit cancels out. So now the density of gold was 19.3 grams per milliliter. Is my ring gold? Nope, because those two don't match up. For my ring to be gold, it would have had to match up exactly perfect. It would have had to been 19.3. So I got ripped off. The guy that sold me this didn't sell me real gold. But when I looked at the inside of the ring, right? So if you looked at the inside of it, it said 14K on the inside. What does that K stand for? It actually stands for carat. What carat is that if I have a scale here, if I have a 24 karat ring gold, or ring, then that means it is 100% gold. Okay? If the ring is 0 carat, then it's 0% gold. So what would be half? Well, halfway would be 12 karat. So that would be 50% gold. Well, my ring was 14 karat. So that means my ring was right here. So it was about 60-ish percent gold, 60, 65% gold. Okay. Now, why isn't it 100% gold? Well, gold is really, 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 really soft. And if my ring was 100% gold, you could take my ring and go like that and squish it with your fingers. So what they actually did is they mixed it when it was a liquid, when it was really, really hot, with another metal that was really hard. So, and then you get both characteristics. You get the gold color, so it looks gold, right? But then you also get the hardness of this other metal that they added, so that you can't squish it. Right? Even though it was still soft and it was just, you could deform it, but you had to use like pliers or a rock and you can make it squished. And when I did take it off, it was all deformed. So, but I do have it at home. So now what did they actually make? Because they mixed it together, they made a thing called an alloy. You don't have to know that term for anything. It's just a little extra that you'll hear about out in the real world, is that they make alloys, and alloys are a mixture of two metals when you mix the two of them together to get different properties. And that's something that we do inside of our cars a lot. We mix metals to make it so that we can get different properties, so that our cars have different characteristics about the way in which they run. So, all right, so now what you got to do is now you got to do your homework. There's an assignment to do next concerning density, ultimately. And I believe that'll be tomorrow's assignment. See ya.